So I'd like to turn the Zoom call over to Professor Sama, who will talk about statistics. Okay. All right, Sama, I want you to share your screen.
Hello, everyone. Today we will speak about the sample size calculation. I will give you some tips and tricks on the concepts of sample size calculation for the most common study designs you will implement in your research career. Before I start, I will reintroduce myself again. I'm Samar Abdel Hafiz. I'm an associate professor of epidemiology, High Institute of Public Health, Alexandria University. So, why should we calculate the sample size? Why it's necessary, and what's the sample size? Sample size, or the study population, they are subpopulation to be studied to make an inference on the reference population. And the larger the sample size, the more accurate the findings from the study. So could someone tell me why it's important to calculate the sample size? Why we insist on asking you to calculate the sample size before you start doing your research proposal? Could someone just give me his opinion about that?
Can I answer?
Yeah, of course.
Hi, Jeanette. It's Jeanette here. Because it's not practical to study the whole population usually, and
Yes.
also in resource limited settings. Obviously, you don't want to be studying more people than you need to actually make that inference to the reference population.
So that's perfect. So I need to calculate the sample size because it's impossible to do my study on all the population, and I need to know my limit, the upper and lower limit, because I'm doing this study to infer my findings on another population. So let's differentiate between two populations I'm using in my research. I'm doing my study on the study population, but I'd like to refer or to infer or to generalize my findings on the target population. So what's the difference between the two terms? Let's assume that I want to estimate the prevalence of COVID-19 among the Egyptian population. So it's impossible to include all the Egyptian population unless I have a registry. It's impossible to include all the population in my study. I need to have a representative, so take care of the word, representative sample of the Egyptian population to do my study on it, to calculate the prevalence of the COVID infection. And then this prevalence calculated from my study population will give an idea on the prevalence of the COVID-19 in among the Egyptian population. So the target population is all the Egyptian population, while my study population is the subsample from the target population I'm doing my study on it. Is it clear? Okay, so as it's expected, when I include larger sample size, more accurate findings will be inferred from my study. But to what extent it should be large? I have limits to calculate the sample size, and these limits depends on the availability of resources sets up the upper limit of the sample size, and the required accuracy sets the lower limit of the sample size. So I'm always between two limits. What's the feasibility of doing this study? What is the available resource? And the accuracy or the representation of my findings on the target population I want to set. So why do we calculate the sample size? To provide a reliable answer to my research question, to limit the cost of the study, to be able to conduct a feasible study, and then how large a sample do I need? If the sample is too small, even a well-conducted study may fail to answer the research question. and it also may fail to detect the important effect or associations, and it may associate this effect imprecisely. So if I didn't calculate a sample size before starting my study, I may not be able to have an accurate estimate of the research question I'm trying to answer, or I will not be able to identify the effect. For example, if I want to test the effect of a new drug versus a standard drug, I will not be able to detect this effect, or I may report a false effect. On the other side, if the sample is too large, the study will be difficult and costly, and it may have some time constraints, and the larger may affect the accuracy, because I will lose the accuracy. I will not be able to include a very large sample size, and this may affect the accuracy of my findings at the end. So to calculate the sample size, it's not a matter, or it's not the job of the statistician. The researcher, and all of you are researchers, have a very important role in determining the sample size. If we consider that the sample size calculation is a process with 100%, so the researcher is responsible for 70% of determining the accurate sample size, and the biostatistician is responsible for only 30%. This is why, because the sample size calculation depends on the sample, the population, and of course the researcher is the one who could determine what are the population he wants to test, the variables to study, the magnitude of the study problem, the different statistical analysis methods, if I have dropouts, and the different facilities. Let's take it one by one and have an example for this. So could someone share with me his research question, and then we will apply these items on this research question?
What's the question, Sama?
I want someone to share with me his research question, and then I will explain the different items that may affect the sample size based on the research question shared by one of the colleagues.
You want the research question or the objectives?
No, the research question, just the research question. No one has a research question in his mind?
Can I go?
Yeah.
My research question is, what is the health-seeking behavior of patients using a tertiary facility in Kakamega, Kenya? I'm saying
that's your research. Yeah.
What is the health-seeking behavior, health-seeking behavior of patients attending a tertiary facility in Kakamega, Kenya?
Okay, so your research question is this: the health-seeking behavior. You want to estimate the prevalence of health-seeking behavior. Is it right? Among the patients attending?
Well, not exactly the prevalence, but maybe want to know the perceived perception, or the from the user's perspective, what moves them or motivate them to seek eye health during the in the facility for a particular period, for instance, during the COVID-19 period, or what barriers do they have in assessing eye health?
Your primary variable or your primary outcome is what you want to measure. How will you summarize your data at the end?
I think the network has a problem.
Your voice is not clear for me, so I'm not hearing well.
Okay, let somebody else try. let me change my position. Maybe it's my network.
So let me
Sam, are you able to give an example yourself?
let me suggest a research question. I want to assess or I want to determine the incidence of cardiovascular the thrombotic problems among population who get the COVID-19 vaccine. So who should be the sampled population in this situation? The sampled population should be the population who got the COVID-19 vaccine. And what is the variable to be studied? The variable to be studied is the incidence of the thrombotic side effects. So I want to summarize my data at the end. I want to report the incidence of the thrombotic events. And what's the magnitude of the study problem? If this has been done in another country, they reported, for example, as reported by the study for AstraZeneca, that the incidence of the thrombotic side effects among people who got the AstraZeneca vaccine is 4 in million. So this is the magnitude based on the previous study. What's the statistical analysis methods? I will not do any complicated statistical analysis. I just want to report the incidence. I will not determine what are the associated factors for those who get higher incidence versus lower incidence. So as simple as it is. What's the dropout? I'm expecting, because this will need me to follow the patients or to follow the population, I'm expecting that I will not be able to follow all the study population. So I need to increase the sample size to overcome the problem of the dropout. What's the facility? Will I be able to do it door by door? So I will do it on community based, or I will go to the health units and I will pick the population who are recently getting their vaccine. So these are the questions to put it in my mind when determining the sample size. And those questions are answered by the researcher, not the statistician. Okay? We have a very huge number of mathematical equations to determine the minimal proper sample size needed for a study. And they're done usually on the most important primary outcome of the study. And who could determine the primary outcome of the study? The researcher is the one who is responsible for determining the primary outcome. If you have more than one primary outcome, you should do the calculations for each one and then select the largest sample size. So if you want to determine more than one primary outcome, the statistician will calculate the sample size for every outcome, and then we will get the larger sample size to be considered in your study. And also, if you have complex relationship between different variables, then the calculation will be complex, generating also a larger sample size. Many equations exist and no evidence that one is better than others. And most of the calculators present on the websites, they are valid for calculating the sample size. You just need to know the givens or the determinants of the sample size. So what are the entries of the equations are? The type of the study design, the type of data of the target outcome, whether it's a quantitative versus qualitative. This study will be comparative or not, and this comparison will be paired or unpaired. I will explain each one. The primary statistical relation used, and 2 other determinants, and those 2 determinants, they are the responsibility of the statistician, something which is called the alpha error, and usually we put it at 0.05, and the power, and for all observational studies, it's set at 80%. Let's start one by one.
Sama, what do you mean quantitative versus qualitative?
Yeah, I will explain immediately.
Okay, I can wait.
Okay, so let's start one by one. What are the different study designs we usually do in our research? Could someone tell me the classification of the different study designs we have? Or do you have an idea about the different study designs?
You mean something like descriptive, cross-sectional,
Yes,
experimental, analytical,
exactly.
case control, cohort, and so forth.
Yeah, perfect. So in research, we have two main families of the study designs. No one of us will do his study unless he considers one of the study designs. We are going to give an idea on it immediately. We have a group of studies which are called observational study designs, and the other group is experimental or interventional study designs. The observational study designs are the group of study designs in which the researcher is responsible for observing what's happening only, while the experimental study designs, the researcher intervenes by a way or another. He wants to test the effect of health education program. He wants to test the effect of a new drug. He wants to test the effect of a new surgical technique. So he intervenes by himself. The observational study designs, and this is the focus of our presentation today, because most of us in our region are doing the observational study designs. We sub-classify them into three main families: cross-sectional study designs, and this is the survey designs, and case control and the cohort study designs. In cross-sectional study designs, I'm aiming to determine the prevalence of a certain problem. So I want to determine the prevalence of hypertension. I want to determine the prevalence of hepatitis C infection. I want to determine the prevalence of a certain problem, the proportion. For example, if I want to determine the knowledge of a group of population regarding a certain issue, and this knowledge will be classified that some people are knowledgeable and some are not knowledgeable. So I have the prevalence at the end of the story. I will have the prevalence of those people who are knowledgeable regarding a certain health problem. So this is the measure which is calculated from the cross-sectional study. What about the other two types of the study designs, the observational ones? We have something which is called the case control and a cohort study. Regardless the differences between both these study designs, I want to estimate, or I want to determine if there is an association between a certain exposure and a certain outcome. I want to determine if the people who have diabetes will develop renal impairment or not. So I have two factors, I have two variables, and I want to determine the relationship between these two variables. When I have two variables and I want to determine the relationship between these two variables, I need to do what's called comparative design. And in comparative design, I have something which is a case control and a cohort design. As it's a comparative design, I should have in my study two groups: cases versus controls, or exposed versus non-exposed. Please, if something is not clear, just stop me and ask, okay? So these are the three main types of the study design I'm usually using in my observational research plan. This is not the main issue. I have another concern, which is the type of the data of the target outcome, quantitative versus qualitative. What does it mean? If I'm calculating if I want to estimate or determine the knowledge of a group of the population regarding a certain condition, I have two options to summarize my data at the end of the story. Either to report the score of the knowledge, or to categorize the population as knowledgeable and non-knowledgeable. Is it clear to now or not?
Sarah, it's not clear to me. What distinction are you trying to make here?
I want to differentiate what does it mean, the quantitative versus the qualitative. So I have my parameter to assess is the knowledge of the population regarding a certain health problem. The knowledge at the end of doing my study, I will summarize my data either by calculating the total score and presented by mean and standard deviation, or categorize the knowledge based on a certain cutoff point and conclude that some population are knowledgeable and some are not knowledgeable. When I summarize my data based on the mean and the standard deviation, then I considered the variable as quantitative variable. While when I categorize it based on a certain cutoff point, I considered the variable or my outcome as qualitative variable. Let's have another example. I want to assess the blood pressure among population who complain of cardiovascular problems. So at the end of the story, I have two options to summarize the blood pressure. Either to report only the systolic blood pressure, the mean and the standard deviation of the blood pressure among cardiovascular patients, or to categorize the patients as hypertensive versus non-hypertensive. When I considered the outcome being summarized as mean and standard deviation, then this variable is called the quantitative variable because I dealt with it as a quantity. While when I categorize the population or the patients as hypertensive versus non-hypertensive, I dealt with the variable as a qualitative because I categorized it. Is it clear?
Okay, well, I mean, I understand the distinction. It just gets a little confusing because qualitative data refers to social science research, interviews, focus groups. So it gets a little confusing to use the same word for different things.
Okay.
So,
Can we rephrase it like categorical data? The categorical variable?
The categorical variables are subgroup of the qualitative variables because the qualitative variables could be categorical, could be binary. So we have a lot of groups under the qualitative. So usually we use the word or the term qualitative to refer to the categorical variables and the binary variables. But it's the same idea.
Okay, it's fine. It's just when I first saw qualitative data, I thought of qualitative research.
Okay. No, it's not qualitative research. We use the quantitative and the qualitative in differentiating the different types of the variables or the outcome.
Okay. All right, good.
Okay. The third determinant for the sample size calculation is this comparative design is paired or unpaired. What does it mean? Sometimes we hear that that someone or a researcher will do his study to assess the effect of a certain drug or a certain health education program on the same group of the population. So he recruited a group of the population and he assessed the parameter, let's say the blood pressure. Then he gave them a certain drug and reassessed the blood pressure among the same group. At the end of the story, this researcher wants to compare between the baseline measurement and the measurement after the treatment he gave. He's doing his study on the same group of the population, and he compared the blood pressure before and after the intervention. In this case, in statistical term, I called that this group, I will do a paired analysis because I'm doing the study on the same group of the population, and I wanted to test the effect of the drug before and the effect of the drug on the blood pressure before and after the administration of the drug. So in this scenario, if I'm doing my study on the same group of the population, It's called a paired study. I have another scenario. I have the same drug, and I will administer this drug to a group of population, and I have another group of the population. Among them, I will not give them this drug, or I will give them standard therapy. So I have two different groups, and I want to test the effect of this drug between the two groups. If I have two independent groups, then in this scenario, this is study called unpaired comparison. So to determine the equation, I need to know what study design I will consider. I need to determine what's the type of my outcome, the primary outcome. Will I summarize it as a in a quantitative way or a qualitative way? If I'm doing the comparative design or I'm doing the comparative study, like the case control or the cohort, will I compare before and after, or I will include two different populations? Then the primary statistical relation used, will I consider doing also only reporting the percentage, or I need to do a regression analysis, a correlation analysis, a chi-square, a t-test. So it depends on the primary statistical relation used, and this could be determined with the help of the statistician when you tell him exactly what you want to assess in your research. The other two terms that use to calculate the sample size, two types of errors usually set at 0.05 for the alpha error and the power 80% for all observational studies. And these errors, they are predetermined errors I'm putting in my equation to be taken when calculating the sample size, because as we said that the sample size, I'm doing the study on the study population, and I want to generalize my data on the target population. So in all cases, I will commit a certain error in my study. So I predetermine this error to consider it when calculating the sample size. The last thing to consider when calculating the sample size is the ratio between the cases and controls, or the two groups I am comparing between them. So if I have a study with two independent groups, I need to say what is the required ratio between the two groups. And put it in your mind that the minimum accepted ratio is 1:1. So the controls or the unexposed group or the group who is going to take the standard therapy, its ratio should be at least equal to the other group or more than it, but not less than it. Okay. So if something is not clear, just unmute yourself and ask me, because I'm not able to follow all the comments on the chat box.
I'm monitoring the chat box. Don't worry.
Okay.
I just raised my hand though, Jeanette here.
Okay.
I was wondering if you could please go over the power as well.
You want to understand the power?
Yes, please.
Let's explain it if we have some time at the end, because it needs some basics before explaining it, and I'm afraid that the presentation, we will not have a sufficient time for this. It needs
in one sentence or two, basically, what is the concept of power?
Okay, the concept of the power is simply to what extent I'm confident or I'm sure that what I will have in my study reflects the real situation. What does it mean? I will conclude at the end of the story that those who have diabetes are more liable to get renal impairment compared to the non-diabetic patients. And I concluded I have the evidence. I reported some findings, statistical findings from my study, and these findings are significant. It means that the findings reported that diabetic patients are significantly at higher risk to develop renal impairment compared to the non-diabetic patients. to what extent I'm confident or I'm sure that this will be reflected on the all diabetic patients versus the non-diabetic patients. This is the concept of the power. So the power is what I summarize from based on my data reflects the real situation. So I'm 80% confident that the population who have diabetes will develop renal impairment compared to the non-diabetic patients.
So generalizing, 80% confident that what you have observed from the study population will be generalizable to the general population?
No, this is the confidence level. So the 95% confidence level reflects that the concept of generalization, while the power reflects that to what extent I'm sure that my findings are correct, simply.
Ah, okay, gotcha. Thanks.
So the confidence level, let me finish and then because I got to the confusion here. The confidence level reflects the generalizability. So I'm 95% confidence that if someone has, if this study is repeated 100 times, I'm deadly sure that 95% or 95 times of the 100 times, they will have the same findings as I found in my study, okay? While the power reflects to what extent I'm sure that my findings are correct, my findings in the study.
Yes, thank you.
Okay.
For me, that's still a bit confusing.
Why? So where is the confusion? Tell me.
I'm going to tell you right away. So, confidence interval tells you the level of confidence with which you have that your findings are correct, right?
No. This is usually misinterpreted like this. The confidence does not tell you that you are deadly sure that your findings are lying between the lower and the upper limit of the confidence interval. It tells you that this study, I'm doing this study in Alexandria, in my city, and someone else is doing the same study with the same techniques in Cairo, and someone else in Upper Egypt, and etc. So if this study is repeated by different researchers 100 times, I will be sure that among the 100 times this study is repeated, 95 times they will have the findings that lie between the lower and the upper limit of the interval I put for the summarization. I will tell you. I determined the prevalence of the hypertension in Alexandria, among Alexandria population, and it's 20%, okay? And I said that the confidence interval, the 95% confidence interval of this 20% prevalence of the hypertension is between 15 to 25, okay? So what does it mean 15 to 25? 15 to 25 means that I am sure that if this study is repeated among the Egyptian population by different researchers, so not me, 100 times, 95 times of these studies will have the prevalence of the hypertension to lie between the 15 and the 25. So I gave you this range, and I tell you that I am doing this study. I'm confident about my sample calculation and the sampling technique. And if you repeat this study, and several researchers repeat this study 100 times, you will definitely have the value of the prevalence of the hypertension among the Egyptian population in different settings, which lie between the 15 and the 25. And I am 95% confident that this should reflect the prevalence of the hypertension among the Egyptian population. Is it clear? The issue of the confidence?
Yes, so in black and white, confidence tells you that if I say, for instance, 15 and 25, and I find a value, I said 95%, I am 95% sure, I'm 95% confident that if you do this thing over again, it will lie between 15 and 25, like you said. So it's my level of trust of my finding, right?
Yeah, my level of trust of my findings to reflect the situation among the target population. As I told you, I'm doing my study on the study population, but I'm looking forward to generalize my findings on the target population. My aim is to assess the prevalence of the hypertension among all the Egyptian population. And this is not, I'm living in Alexandria. So I will do my study on a subsample of the population who are living in Alexandria. To what extent I'm confident that my findings will reflect, could be generalized to the total population, to the Egyptian population, this is the confidence level. The power is limited to the findings of my study. The prevalence of the hypertension based on my study population is 20%. So to what extent I am sure that this value, the 20% value is correct, this is the power.
Another way, it means that what you're saying, if we put it in terms of sample and population, I can say this finding, let's take an example, the prevalence you're talking about, I am 95% confident that this value reflects the truth about the general population. I took a sample out of the general population and I got a finding based on what the sample has given me. And I am 95% sure that this reflects the truth about the general population.
Yes, yes.
I'm trying to put this in black and white because sometimes we state things and just reading it and writing them. But when we are able to put them in black and white, especially I think every one of us somehow are teachers, we're able to relate it back to whoever we are talking to. So that's why I'm trying to repeat it, not using the technical terms, but to put it in black and white. That's why I say, so my finding from this sample, I am 95% confident it will reflect the truth about the general population, right?
Yeah, exactly, perfect. This is
so now what is power? How does power different?
To what extent the number I calculated from my samples, from my study is correct, simply.
Because to be very honest, this thing confused me. I stated it the way the statistician gave me in my PhD, and up to today, I keep stating it, but I can't really tell you I know what I'm writing.
The power is related to your study population, while the confidence level is related to the generalization of your findings. I calculated the prevalence of the hypertension among the subset of the people living in Alexandria, and I reported it. It's 20%. Is it correct or not? I will tell you, I'm 20%. I am 20% sure that this 20%. I'm 80% sure that this 20% is correct. So it's based on my study population. While the 95%, I will tell you that this 20%, which lies in an interval between 15 and 25%, will reflect the situation among the general population, and I'm confident about this by 95%. Could you differentiate now?
Somehow. So what is the meaning of this? When I say the study, for this study, an 80% power for a two-tailed hypothesis at alpha 0.05 and 10% allowance of non-response will dictate a 10% mean utility or mean difference.
No, I didn't get the question. Could you repeat, please?
Okay, I will just copy this and put it on the chat too, so it's easy for you to read it yourself. I just copied my work and the statement that it is. I use the power analysis, which actually I'm very interested because that's what I also want to use for this current study I'm doing. So I really need to know what I'm stating.
Flip the coin. Someone is doing a study and he said that I will do my study on 50 patients, okay? And then he calculated, he assumed, his research question is, I want to test the high level of a certain biomarker among those patients, okay? And he assumed that when this biomarker is high, those patients are more liable to get a certain disease, okay? And he didn't calculate a sample size. He just considered that the kit he has for this biomarker will be sufficient for 50 patients. Then he said, okay, I will not use more than one kit, so I will consider only 50 patients. And then he did his study, and he wanted to publish the findings of his study. Then what's the situation for the reviewer to check to what extent the high level of this biomarker among patients? As a reviewer, I will calculate the power. I don't have the tools to calculate the new sample size, and he already did his study on 50 patients. Then I will calculate the power of the analysis. What does it mean? He says that among the ICU patients, a certain biomarker is high, and the cutoff point, and this biomarker is usually high among the ICU patients, and 35% of the ICU patients will have a high level of this biomarker. And he reported that 35% of the ICU patients will have this high biomarker. To what extent that this is real, this is precise, that really ICU patients have a 35% high level of this biomarker. Then I will calculate the power. What's the power? To what extent this 35 is precise? Sometimes I will have the power less than 80%. Then I will report it to the researcher. I'm sorry, your findings are not, your findings don't give me a sufficient power to consider that really this biomarker is high among the ICU patients. Is it clear or not?
Somehow it's clear.
Yeah. Could you please give an example how to calculate the power?
No, it's not in our concern now.
How to link it to sample size?
It's usually put by default power 80%. If you want to do how to do power analysis, then we need to have another presentation, because we have two issues, either sample size calculation or power analysis. Usually in observational studies, we set the power at 80%.
Mm-hmm.
So if you need details about the power and the alpha error, we can arrange with Professor Henry to have another presentation on the types of errors in research. And in this presentation, we will have the details of the concept of the power and the alpha error, because it depends on the hypothesis testing, the null and the alternative hypothesis.
Okay.
The
Because
concept of the power and the alpha error depends on the hypothesis.
Yeah, I used to think that level of confidence is how I'm confident about my results. As Emmanuel explained earlier.
Confidence is to someone.
Okay, so it doesn't have to do with the power with the statistical test, because I used to know that it's about the power. Parametric and non-parametric statistical test would contribute to the level of power.
No, usually we set the power at 80% when we are doing an observational study and 90% when we are doing an interventional study. If you are interested in these concepts, because I don't know what are the different backgrounds of the group related to the statistics. If you are interested in the concept of the hypothesis testing and its relation to the alpha error and the power analysis, we can give another presentation on it.
Sam, are you going to give an example of calculating sample size from online software?
Yeah, we have 6 examples on the calculating the sample size, and we will do it by ourselves now. So just
I'm not sure we're going to have time for everyone to do it themselves.
No, I will do it as a demonstration, and I'm putting the links for the different calculators, and they can do it by themselves when they take the presentation.
Okay, all right, good.
So maybe Professor Samia, you it's part of what you tell us when to use a power analysis and when not to use it. Because I've seen a situation where I tell my students that use a power analysis of, say, t-test or ANOVA, and during the presentation, some reviewers will say, no, you can't use a power analysis because it is not comparing. So do you only use it when you are comparing two variables, or you can use it at any time, so long as it's a descriptive study?
We use it at any time. And if you want to do the power analysis, as I told you, if you did your study on a group of population without determining the sample size, then the reader needs to know to what extent he will be sure that your findings are correct. In this scenario, he will do this power analysis.
Okay. So it's an alternative to sample size calculation, right?
Sorry?
It is an alternative. If I don't want to calculate sample size, I can determine the power to which it is correct. My hypothesis will be correct, right?
Exactly, perfect, exactly.
Okay.
Oh, wait a second, now I'm a little confused. I thought the sample size is depends on what power you want the study to be set at. Aren't they interrelated?
The power and sample size are interrelated, yes, but some people are not calculating the sample size before doing their studies. And in this case, I can calculate the power from their findings and determine whether these findings are powerful or not. And the cutoff point for telling that the findings are powerful or not is 80% when I'm doing an observational study and 90% when I'm doing an interventional study.
Right, okay, no, I mean, that's fine, but I think Emmanuel left his last concept as saying you could either calculate sample size or calculate power, but that makes no sense because at the end of the day, you need to know how many studies, how many participants to recruit for the study. And if you want, power is typically set at 80%. So you have a good chance of detecting a difference when there is a difference. And you know, you have an 80% chance. Of course, the flip side is that if your power is too high, then you're going to be very sensitive and you're going to say you have a difference when actually you don't have a difference.
So it's a trade-off, you mean?
Well, there's always a trade-off when it comes to statistics. Again, you want it high enough so that you the chance of detecting a difference when there is a difference. A problem with a lot of studies, with the negative studies, is that you say there's no difference, but let's say I do a study with a sample size of 10. The chances of me detecting a difference is very, very low. So that the power of that study is very low. So I want to increase my sample size so that if there is the whole point of, well, one of the points of research is that if there is a difference between your two groups, you want to be able to detect it, okay? And hence that means you have a sufficient power in that study, which depends largely on the sample size. Now, on the other hand, you know, like when you do, someone asked the question about too large of a sample size. So in cardiology studies, in which, you know, a lot of people have heart conditions, so it's very easy to enroll thousands and thousands of patients, okay, and to see the difference between the two groups. And let's say you have a difference in mortality of 1% between the two groups, okay? If you enrolled 50,000 patients, okay, your statistics will show a p-value of less than 0.05. and you're going to say there's a difference between that mortality. So that's where a large sample size will get you into trouble, as well as a large power.
Yeah.
I mean,
This is
that's just trying to explain it in real world issues. Okay, all right.
So my question, Henry, would be on your explanation, what factors will determine your decision to either use the z-score parameters as with Fisher's formula to determine the sample size calculation, and what and when would you choose to do a power analysis? Because ultimately, like what you're saying, eventually you want to know the minimum sample you can use for your study. Either you use the Fisher's formula or the power analysis. What factors determine when you make a choice to use either?
Well, I'm not sure if I understand the question, but Sama, why don't you go through an example? I think it's time for an example, if we could have that.
So just to sum up that, as we mentioned, the primary outcome for us could be reported by a proportion or could be a continuous outcome. And we have something which is called the effect size. The effect size is, I'm assuming that the new drug will reduce the blood pressure compared to the standard drug by a certain difference. How can I determine this difference? I can determine this difference if I have records from the previous literature. If I don't have previous literature or I don't have records, I can do a pilot study. And the pilot study usually, I'm usually doing it on a small sample size, or based on the clinical experience. Let's say that the standard drug is usually reducing the blood pressure among diabetes patients, and the mean of the systolic blood pressure among the diabetes patients who are taking the standard therapy is 130. So I will consider the new drug is effective if it reduces the blood pressure by 125. And this value could be retrieved based on the clinical experience. The clinicians will say that I will consider the new drug is effective when it's able to reduce the blood pressure by 125 compared to the 130 by the standard therapy. And the standard effect size, it's the last option for us. On the software calculators, we usually have some values for the effect size, and they say that will you determine the difference between the two groups to be 0.2 or 0.3, and they are predetermined, but this is not the best option for us. The most usable program for us to calculate the sample size is the EpiInfo program. So let's take an example and see how well we calculate the sample size. Consider conducting a cross-section study to evaluate the prevalence of post-traumatic stress disorder among ICU patients in Alexandria Teaching Hospital. The literature revealed that the prevalence of the post-traumatic stress disorder among the ICU patients was 32.3. And the population size is estimated from a previous study on ICU patients in Alexandria Teaching Hospitals, and the study reported an average of 1,278 ICU patients attending the hospital every year. So what should be the sample size? What's the outcome here? Hi guys, what's the outcome here?
ICU patient prevalence of PTSD among the ICU patient was the outcome.
Okay, so the outcome, the primary outcome is the prevalence of the post-traumatic stress disorder. What's the type of the study?
Observational study.
Cross-section study. Okay, perfect. And what's the reported prevalence based on previous literature?
32.3%.
And what's the total population, the target population, the number of the target population in this case?
1278.
Perfect. So now I want to calculate the sample size. Let's do it by our. Okay. Are you still seeing my screen?
Yes.
Yeah, we see your PowerPoint.
Okay. So I will you share. Okay. For all of the observation studies, we are using the EpiInfo program to calculate the sample size. And I'm putting the link for the calculator in the presentation. So here, this is the first interface of the OpenEpi. I want to calculate the sample size. So I will go to the sample size. And this type of the study is a cross-section, and my outcome is a prevalence. So it's summarized as proportion. In this case, what's the type of this variable? Is it quantitative or qualitative?
Qualitative, either having post-traumatic or not.
Perfect. So I'm depending on the proportion to conclude my findings. So the sample size based on the proportion. Now I will have this window, enter new data. What's the population size? It was 1,000.
278.
Okay. What's the prevalence? It's 32.
52.3.
Okay. The confidence or the confidence limit or it's the complementary of the confidence level. So I have the confidence level of 95%. So the limit is 5. It's the default. And the design effect, keep it as 1 as long as you are doing your study in one setting. So I'm doing this study in Alexandria Teaching Hospital. If I am doing this study in all hospitals in Alexandria, I will need to, of course, to increase the sample size. So I will put the design effect as 2. But in our scenario, it's here 1. Okay. Then I will calculate the sample size. Now, at a confidence level 95%, the minimum required sample size is 266. So this is the sample size for this research question, which is what's the prevalence of post-traumatic stress disorder among ICU patients in Alexandria Teaching Hospital? Is it easy or not?
Easy.
Okay. Now the other type of the studies we have the comparative studies, and we mentioned that we have case control studies and a cohort study. The measure that is calculated from the case control is the odds ratio. What's the odds ratio? Simply, it's the division of the proportion of the population who are exposed to a certain risk factor among patients versus the proportion who are exposed among the controls. I have a group of the population who have renal failure. So those are the cases, and the other group is without renal failure. And I want to determine the association between renal failure and the history of diabetes. So I need to know the proportion of diabetes among the renal failure patients versus the proportion of the diabetes among the non-renal failure patients. When I divide the first...
Sam, slow down. The previous example, I'm a little confused. What statistical analysis? I mean, you say the outcome of the study was the percentage of patients with post-traumatic stress disorder. So, I mean, that sounds like a descriptive analysis.
Yeah, very, very, very descriptive.
So what? I mean, the sample size, I don't understand. What was the purpose of doing a statistical analysis? I mean, it's just, I don't understand what the sample size is. The sample size of 266 tells you that at that sample size, I don't know, maybe I'm the only one having this problem. It's still only Monday morning. I get better throughout the week, but let's say if I did a sample size of 100, what does that mean? That I didn't calculate accurately the
sample size, yes.
but so what does that tell me?
So you want to consider a sample size of 100?
Are you saying that if I get a percentage of 32%, it may not be correct? The prevalence may not be correct?
Or what? No, I didn't understand.
Well, I mean, why do I need a sample size? I want to have an accurate value for the frequency.
Yeah, for the prevalence. So based on previous literature, and this study was done in another country or nearby, in Cairo, and they reported that the prevalence of post-traumatic stress disorder among ICU patients was 32.3. So what's the situation in Alexandria? And this is my research question. I want to know what's the proportion of ICU patients who have post-traumatic stress disorder. I need to calculate.
Okay, all right, so you need a sample size of blah, blah, blah to get a good frequency. Okay, could you give an example of when you want to detect a significant difference between two groups?
Yes, this is what I would just.
Okay, very good. Thank you.
Okay, so the other scenario is I want to compare between two groups, and in this scenario, I will use either a case control or a cohort study. In the case control, as I mentioned, this example, for example, I have a group of patients with renal failure versus a group of population without renal failure, and I want to determine the association between renal failure and the history of diabetes. Then the exposure here is the diabetes mellitus. In this scenario, I will need to know the percentage of the diabetic patients among the diabetes among the renal failure patients and the percentage of the diabetes among the non-renal failure population. If I divide the first proportion versus the second proportion, I will, by a simple technique, I will have what's called the odds ratio. So to calculate the sample size for a case control, I need to have the odds ratio, the percentage of exposure in the controls, or the percentage of exposure in the cases, and the same settings for the power and the alpha error, and the ratio between the cases and the controls. And in this case, as I mentioned, that the percentage usually is 1:1 or more than 1:1. Let's take another example. Assume that you conduct a case control study to test the association between hepatitis C virus and hepatocellular carcinoma. Based on the previous literature, and this is the reference, the odds ratio of association between the exposure to hepatitis C virus infection and developing hepatitis C virus hepatocellular carcinoma was 5.1. And the proportion or the percentage of the anti-hepatitis C virus antibodies were present in 42.9% of the control group. So what should be your sample size? So my research question here, I want to test the association between the history of hepatitis C virus and the hepatocellular carcinoma. What are the two groups here in my study? Could someone tell me?
Hepatitis C virus and hepatocellular carcinoma.
Sorry?
Hepatitis C virus disease and hepatocellular carcinoma.
The first group will be?
Hepatitis C virus, HCV.
What's the exposure here and what's the outcome?
Exposure HCV and the outcome is carcinoma, hepatic carcinoma.
Perfect. And in this scenario, I want to test if there is a relation to hepatitis C virus infection and hepatocellular carcinoma. In this case, I'm assuming that population who have hepatocellular carcinoma will have a higher proportion with hepatitis C, the proportion of hepatitis C virus infection among patients with hepatocellular carcinoma is higher among those without hepatocellular carcinoma. So I'm comparing the population with hepatocellular carcinoma versus whom? Versus whom?
Isn't that those exposed to HCV and those not exposed, or rather those having hepatitis and those that are not having it?
Perfect. So in this case, in the case control study, I'm comparing population with hepatocellular carcinoma versus those without hepatocellular carcinoma, because the case control study starts with the disease status, and what's the outcome here, or the disease status, is the hepatocellular carcinoma. So the case control study is a study that is defined based on the outcome. Here, the research question is, I want to test the relationship between hepatocellular carcinoma and hepatitis C virus. I have two options, either to compare patients who have hepatitis C virus versus those who don't have, or those who have hepatocellular carcinoma versus those who don't have hepatocellular carcinoma. In case control studies, I'm comparing based on the outcome. What's the outcome here is hepatocellular carcinoma. So what are the two groups? Patients with hepatocellular carcinoma versus population without hepatocellular carcinoma. And then I want to test the percentage of hepatitis C virus infection among the hepatocellular carcinoma patients versus those without hepatocellular carcinoma. Is it clear? What are the givens here? I have an odds ratio of 5.1, which reflects what's the meaning of 5.1 odds ratio, that those with hepatocellular carcinoma have 5 times higher risk to give history of hepatitis C virus infection compared to those without hepatocellular carcinoma. Clear?
Yep.
Okay. And what's the percentage of the hepatitis C virus infection among the population? The control in this scenario is the population without hepatocellular carcinoma is 42.9. So I have these two givens. How can I calculate my sample size? I will be back to the same epi-info. And this, what I want to do here, I want to calculate the sample size. What's the type of this study? It's unmatched case control, because I'm not doing any matching here. I will enter my data, the same, it's a confidence is 95, the power is 80, the ratio of controls to cases, the minimum ratio is 1. What's the percentage of the control exposed based on the literature is 42.9.
0.9.
Okay. And what's the odds ratio? The odds ratio 5.1. Okay. This is sufficient for me because I give the software calculator the odds ratio and the percentage of the control exposure. The software will automatically calculate this. So then I will calculate. I will have the sample size. So what's the total sample size? It's 60. The minimum required sample size to have 80% power to have an odds ratio of 5.1, testing the association between hepatitis C virus infection and hepatocellular carcinoma is 66. So I need 66 total sample size to be distributed as 33 cases with hepatocellular carcinoma and 33 patients without hepatocellular carcinoma to be able to detect this odds ratio among my study population. Is it clear?
Sorry, can you talk about Kelsey flays and flays with case control?
No, please, it's not our issue here now.
Okay.
I don't.
So I really need to know why you are using flays with CC. Okay. Okay. Just a question, Prof. When this is because you have the EpiInfo software, does it mean that for me to do this, I need to have an EpiInfo software?
It's a free software calculator. So you can just, when you have the presentation, you will copy the link and it will open with you. So it's a free one. You
okay,
can do
kindly
it.
copy and paste on the chat too.
Yeah, because you will have the, okay, it's here. The chat is disabled.
Oh, okay.
What do you mean it's disabled?
Yeah, it was disabled, Henry.
Why? I've been posting messages.
I think you're the only one who can post as the host. Is disabled.
Yeah, I cannot put the link here.
No, other people has been posting.
After you posted the power, I wanted to say thank you, and I couldn't, and it said chat disabled.
And it's the same for me.
Yeah, I can see them. Chat is disabled too. You can see it. You can look at the end of the chat. It's written there, chat disabled.
I don't see that.
At the bottom of the chat.
Oh. What about now?
Yeah, it's okay. Now it's yeah, it's okay now.
Okay, chat away.
Okay.
Why don't I tell you
So
what? Listen, Sama, why don't we finish up? This lecture, this presentation was not meant to give an entire course in statistics. Okay.
Okay.
It was mainly about calculating the sample size, which a lot of you are doing quantitative studies, and you need to calculate a sample size, okay, in order to send your protocol to the IRB. So, I mean, as I said before, this was not meant to be an entire course in statistics. So I think, why don't you finish up? This has been a wonderful introduction. And Sama, why don't you send me some examples of calculations that people could do in calculating sample size on, short scenarios like what you've been giving, and people could post their answers on the website, and then you could give model answers.
Okay.
How's that?
So you want me to stop here?
Well, let me just finish up whatever concept you were talking about.
No, we have three more examples for the calculations based on the different scenarios we could have or we could face.
Okay. Well, I mean, how long will that take?
Maybe 15 minutes on.
15 minutes. Right. 15 minutes. Okay. Why don't you give two more examples? Because people's time is getting limited.
Okay. So this is another example, and in this case, I'm doing a cohort study, and I want to investigate the impact of literacy on the grand multiparity. And I define the grand multiparity as those who are parents for 5 times or more among the child-bearing women. So I searched for different literature, and I found a study done by Seymour in 2016, and they reported that the risk ratio is a concept similar to the odds ratio, but it's peculiar for the grand multiparity among women who received less than 5th grade literacy compared to those with more than 12th rate literacy was 1.94, and the percentage of the grand multiparity among those who received the higher education was 20.6. So what will be our sample size? I will go to the same software, and it's a cohort study. So now I have chosen the cohort study. The same scenario, it's the confidence level 95, the power 80, and the ratio 1. The percentage of the unexposed among the outcome, here it's 12.6. And the risk ratio in my scenario here is 1.94. Then I will calculate the sample size. The total sample size will be 372, which means that I need to consider 186 women with low education versus 186 women with higher education. Okay. Sometimes I have what's called the correlation analysis. What's the correlation analysis? I want to test a relationship between two variables. And this relationship is determined by type of analysis called the correlation analysis. So what are the requirements when I'm doing a correlation analysis? I need to have what's called the correlation coefficient, the same statistical power of 80 and the alpha error of 0.05, and the correlation coefficient for the null hypothesis, I'm usually setting it between 0 or 0.2. What's the correlation? Let's take an example to make it clearer. I want to conduct a study to test the correlation between a certain biomarker, and it's called the NAGAL, and the serum creatinine level among critically ill patients on day 1 of ICU admission. What's the aim of this? They assumed that the literature says that if there is a strong correlation between this biomarker and the creatinine level among the newly administered ICU patients, they have a higher probability to have acute kidney injury during their stay at the ICU. So based on the literature, they found that there is a strong correlation. There is a correlation between the NAGAL and the serum creatinine. And this is the only study I have, and I want to calculate the sample size based on this value, which is the correlation coefficient of 0.52. 0.52 means that I have a correlation between the NAGAL and the serum creatinine. So for the null hypothesis, to conclude that I don't have a correlation, I will set this value as 0.2. It's an assumption, okay? In this case, I will use another software calculator based on the correlation. I will put it here on the chat for you. And instead of the OpenAPinfo, I will use another calculator. So the first is the alpha error, and we said that we usually put it as 0.05. And this probability, it's the complementary of the power. So some calculators ask me to put the power, and I usually put it as 80%. And some calculators ask me to put the complementary of the power, and the complementary of the 80% is 20%, so it's 0.20. The correlation coefficient in my example was 0.52. Then I need to calculate the sample size. It's here 27. So the total sample size to have a correlation coefficient of 57 is 27. Okay. So going to the last example. I have I want to estimate the mean systolic blood pressure in children with congenital heart disease who are between the age of 3 and 5. How many children should be enrolled in the study? And the investigator plans on using a 95% confidence level, and the standard deviation of the systolic blood pressure is unknown. But the investigators conduct a literature search and find that the standard deviation of the systolic blood pressure in children with other cardiac deficits is between 15 and 20. And the mean systolic blood pressure is 90. What should be the sample size if I have the standard deviation and the mean is unknown for one group of the population? I will use another calculator, and this you can do it by yourself. So So this could be an exercise for you, and you can do it by yourself, and then report the answers on the chat. And this was the last slide for the presentation. Thank you. I hope I was able to give some basic ideas on the sample size calculation.
Thank you.
All right, yes, no, that was good. Definitely a starter in trying to understand all this stuff. And this is, again, start with knowing how to calculate the sample size, and you have the software, online software, but begin to understand what the different terms mean, you know, the confidence interval, the power, and the p-value, and something that we then discuss much, you know, type 1 error, type 2 error, you know, our aim was not to conquer the world today about statistics, but to give you an introduction to whet your appetites so that as you do your research, I mean, one way to really understand statistical analysis and power and blah, 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 is actually do the research. So we all want to make sure you have adequate sample size so that will not be a criticism when you send your manuscript for publication, because a lot of studies don't have adequate sample size. And a good IRB will ask you, how did you calculate your sample size? What assumptions did you make? And so we're trying to start you off. And then obviously, when you get the data, you'll start doing the statistical analysis. And as I said before, for those people doing quantitative studies, we're going to teach you how to use the SPSS software on how to do all these analysis. You know, you're going to enter your data in Excel spreadsheet and convert it to SPSS tables. And I will, for those people doing quantitative data analysis, I will buy you an SPSS license, good for 6 months, so that, and we'll teach you how to use the SPSS, and which is easy to use, but you know, you need to, you know, have some simple instruction. So any questions about all of that?
Question for you or for Samir?
No, just sample the questions in general, not specific questions about statistics. Okay, any questions about what's the goal finally of doing your research? Those people doing quantitative analysis should be able to calculate their sample size, and then later on we'll help you you know, handle the data and do all the different types of analysis. And in fact, as you write your protocol, you want to now determine what kind of analysis you want to do, whether you want to calculate the mean score, what kind of independent variables you have. I mean, the correct way to do all these things is that before you hand in your protocol to the IRB, you actually set up what's called dummy tables. You already know what type of analysis you're going to do. You're going to set up tables that are empty. That's why we call them dummy. Okay, and so you already know what kind of analysis you're going to do. So when you write your analysis section, you actually should give that types of specificity to your analysis. And in fact, we'll probably ask you, tell us now what kind of analysis you want to do, how you want to handle the independent and dependent variables. But that's a story for another day. So we want to give you the tools to analyze your data. So that's what we have in store. We on another general point, it was really good seeing everyone on this presentation. It helps make us a collaborative group, and we would like to have these types of presentations every 2 to 3 weeks, and also we'd like to, once a significant number of people have finished their protocols, we'd like to do some webinars with people presenting their protocols. We want everyone to know what everyone is doing. Okay, we essentially, I say we establishing a collaborative group. Actually, what I'm saying, we're trying to establish a family of collaborators, and I'm really been enjoying myself getting to know everyone by the discussion forums. Any questions about the plans for the next few months? Okay, well, yeah, anytime you have a question, feel free.
Yes, sir. I have a question for Samia, just a clarification, Prof, if you don't mind.
Yeah, go ahead, but as I said, people, why don't you take that offline, Emmanuel? I think it's time to close this session. Why don't you ask Sama offline? Okay.
Okay, that's fine. That's fine.
Okay, right. Okay, so I'm going to send out the recording of this presentation. So everyone have a good rest of the week, and everyone stay safe. Okay, thanks again for joining. Okay.
Bye.
Bye now.
Thank you.